we have to look holistically. We have to look at the human as a system, and especially in the interaction with these environments, because medicine 20 years ago, or the last 20 years, were dominated by single targets, hitting single targets with single molecules, and then, as we all know, it doesn't work.
Right.
So how do you see now that this new approach will really transform medicine and to really generate impact? You know, what will the impact be on medicine and society of this new approach?
Well, I think what a systems approach to disease and to wellness gives us is the ability to understand how a whole series of different biological networks contribute to wellness on the one hand, or become disease perturbed in the context of disease. And for disease, if we can understand how the normal and disease perturbed networks differ, it gives us, I think, deep insights into the mechanisms of disease. But more important, it gives us real clues as to diagnostic markers that could be detecting early transition of disease.
Yeah.
And ultimately, it's going to give us clues as to the therapeutic targets we can use to reverse disease at its earliest stage back to normalcy. And if we can do that for all the common diseases, that will become the preventive medicine of the 21st century, and I think really change people's lives.
Yeah, I mean, I especially like the idea that with this approach, biomarkers at the same time become targets because it's firmly anchored in a mechanism.
Yep.
And the biomarker, which tells you something about the disease, at the same time can change the course of it.
Yeah.
And I think that's beautiful conceptually, but very powerful practically as well.
Yeah.
So,
and I think a beautiful illustration of that was the lung cancer biomarker study we did, where we went from almost 400 proteins down to 13, and we were able to show that 12 of the 13 proteins mapped into 3 of the major disease-perturbed networks in small cell lung cancer. So the filters we use to go from a large number of proteins to the diagnostically functional proteins also reflected the biology that they participated in.
I think there's also a very important aspect, because there's a lot of worries, you know, when we have all these diagnostic means and these new technologies. Can we actually afford to deploy them? Will be the cost so high, you know, that we can't afford this? But what do you think about this aspect?
Well, that's why I think technology is so important. And I actually talked in my lecture today about a new type of protein capture agent that I think will replace antibodies. And we're actually already employing these new capture agents to create protein ELISA assays that will require a fraction of drop of blood, no mass spectrometry, no complicated preparation of the serum or anything else, just a drop of blood, and we'll be able to say whether you have a benign or a neoplastic nodule in your lung.
So even though these technologies are expensive to deploy at the discovery stage, through smart improvements, they'll become fairly cheap, rolling it out to the...
Right. And we have to do it at the discovery stage, that is mass spectrometry, because it lets us look at hundreds of things. But when we get to the point where we only have to measure 2, let's make it as simple as we can and as easy as we can.
So I think that really will transform healthcare, but also has a big impact on society. So do you think countries like Ireland, you know, would benefit from such an approach?
I think Ireland is uniquely positioned in many ways to not only benefit from such approach, but to take a leading, pioneering role in this kind of approach. And I say that because on the one hand, you have many of the biggest pharmaceuticals represented here, and they could be logical partners in pushing this kind of thing forward. I get the feeling that it's possible to get done things in Ireland at a rate that you rarely see in the EU.
Yeah, I mean, this is actually true. When we set up Systems Biology Ireland 6 years ago, we started working with industry partners, and now we work across a lot of industry partners, from computing to biomarker companies to pharmaceutical companies. And using systems approaches, and I must say it is actually a very inspirational work because you can see how very basic concepts of biology translate straight into translation.
Absolutely.
And you can see, the path to the patient, and that's nice.
That's really nice.